Good morrow, good afternoon, or good evening to my fellow lecturer, my fellow tutors, my fellow friends, and dear viewers. Today I'll be talking about my applied machine learning assignment about bird classification. So, the first step of classification, of course, is the data collection. So, this data was provided to me by the assignment, which is split training and test data sets with 2,000 images of birds each. All these images are in the JPEG format. Images are sourced from Caltech UCSD Birds 2011 dataset, and additionally the label text were added for both datasets in a separate folder. Because it is already all in JPEG images, no further modification were done on the dataset, no cropping, no modification in color, nothing. Then we move on to step 2, which is pre-processing. So within the file explorer, the dataset is put into a set structure to fulfill the required format for learning models. Within the AML folder, there are the datasets and the labels. Within them, there are also the training and test files, respectively. Images are transformed in an effort to regularize the image format, which is resizing to 224 times 224 format for ResNet models and 229 times 229 for inception models. Images are randomly flipped horizontally and then formed into a tensor image. Lastly, the image will be normalized in preparation for training. Classes are calculated for testing purposes, which will be done later, because it counts how many species are within the datasets. How do we know these? The classes are attached to the end of the image label within the text files. Now it is time to train the models. There are multiple learning algorithms that can be used for this multi-class classification, and 3 are chosen for this project. The first one is ResNet 50, which is a computer vision model based on CNN. It uses residual networks, which lets model pass through information by skipping layers. There are 50 layers, hence why it's called ResNet 50. And it strikes a balance between fast learning and high accuracy. However, it is prone to overfitting in small datasets. Of course, now we have ResNet 50. You also have ResNet 101, which is deeper than ResNet 50 with more layers. And they're also pre-trained for classification already. However, they are longer to train and also prone to overfitting. Lastly, to shake things up a little bit, we have Inception V3, which contains auxiliary classifiers to help smoothen the gradient of model accuracy. It also factorizes large computation to reduce parameters needed, and it also consumes a lot of power and requires a lot of memory to run. And it also has the highest chance of overfitting. Henceforth, we shall experiment with all 3 of them, but currently the main one is ResNet 50. First, the model will be loaded into a pre-trained model from ImageNet v2 as the model weight. Parameters are frozen for the base layer. This is the pre-trained model, which is best not to be touched. Models go through cross-entropy loss. This is a loss function. And it also goes through the Atom optimizer for 0.001 learning rate and 0.001 weight decay. Device is then mounted on collapsed limited T4 Python GPU. And when it's not available, it will run in Python 3 CPU instead. Images go through a linear transformation through the model's learning algorithm. And the model is trained for 10 epochs for ResNet 50, 8 epochs for ResNet 101. And loss will be reported by the output every epoch with a batch size of 4. And then, of course, the model paths are saved. Similar thing will be done for inception, except we'll also go through an equal 0.001 learning rate and weight decay. And also, the images will also be accompanied by the auxiliary classifiers. The model is also trained for 20 epochs instead, with loss being reported by output every epoch with a batch size of 32. Model path is saved. After this, the model is then evaluated, and based on these metrics, the top one accuracy, which is the accuracy at which the first prediction of model is predicted and to be correct. It seems to be that the ResNet 50 is the lowest, with Inception V3 being the highest. However, this is not as important as the prediction, which is visually displayed as well with 20 images, as well as the gross accuracy and per class accuracy also included, which shows a reverse trend actually, with Inception V3 showing 21.18% gross accuracy and 20.93% average class accuracy, which is, to be fair, a very low outcome as compared to ResNet with 50.96 and 50.13% respectively. This is a classic case of overfitting. So, because of this, ResNet 50 must be fine-tuned. To its high existing test accuracy, ResNet 50 model will be fine-tuned to reduce its overfitting. How do we do this? We transform the image by adding color jitter with certain color aspects such as saturation and hue modified. Other than that, fourth and the fully connected layers of the model are unfrozen so that they could be trained. Linear transformation is replaced with a sequential one. It runs from a ReLU layer, a dropout layer, and then a linear transformation layer. This, you can see there are increases in training and prediction accuracy with a lower loss value and pretty spectacular 72.01 and 71.33% accuracy, though not that high, but it is already quite alright. So with all this done, we finally upload the file. So we decided on using Hugging Face website, which will be deployed for users to play with. It uses a Python file and Gradio as the UI design. It also includes 3 models for users to experiment. It also includes additional classes text file, which maps the label classes into bird species, because people are more interested in bird species than classes, of course. So how do we use this? Users can upload their bird image and choose a model to predict with. To show how it works, let's drop an image right here. Right. We wait for it to upload. Cool. Now you can choose a model here. It's either ResNet 50, ResNet 101, or Inception V3. After you choose one, we will submit. The prediction will show up here. You see, the machine predicts Carolina wren. It's quite simple, actually. Out of the way. This is the link to the site for the Hugging Face, as well as my report. To end the video, I have a quote from Sir David Attenborough. Everyone likes birds. What wild creature is more accessible to our eyes and ears, as close to us and everyone in the world, as universal as a bird? And with that, my video ends here. Thank you so much for watching. Have a great day.